In this lesson, I'll be showing you how to convert from order basis to base 10. I'll be showing you methods for converting from order basis to base 10. The very first method I will show you is the successive multiplication, and the second method is the power expansion. So we're going to start firstly with the successive multiplication. For successive multiplication, if you're given the number a, b, c in base n, we just assume a is the first digit, b is the second digit, and c is the third digit, where our n is our given base. Then we can say the formula for successive multiplication will be first digit times the given base plus the second digit equals first result. Okay, if you look at it here, we have the first digit is a multiplied by our given base is n, then plus second digit, which is b here. That will give us our first result. So we have something like this: a times n plus b equals first result. Then the next thing to do now is to take up this first result and then multiply it by the given base, first result times the given base, then plus the third digit, and that will give us our second result. So we have first result multiplied by n plus c, and c is our third digit. That will give us our second result. So let's look at example 1 on successive multiplication. Convert 415 in base 8 to base 10. So write out your number first, 415 in base 8. And then the next thing to do now, you know that 4 here is the first digit, 1 is the second digit, and 5 is the third digit. And this 8 is the given base. Step 1, following the formula, we should have first digit multiplied by given base plus second digit. That will help us to produce our first result. So what's our first digit here? Our first digit is 4. That means we have 4 multiplied by our given base is 8. 4 times 8, then plus 1. So we have something like this: 4 times 8 plus 1. That will help us to produce our first result. 4 times 8 will give us 32. 32 plus 1, and that will give us 33. So our first result is 33. Okay, we're looking at it step 2. Then the step 2 now will be for us to take this first result and then multiply by the given base and then add the third digit to it. So we have first result and given base plus third digit. That will help us to produce the second result. So let's do that. Our first result is 33. So 33 multiplied by our given base, which is 8. 33 times 8, then plus our third digit. Our third digit here is 5. So we have 33 times 8 plus 5. So you can use your calculator to do that. 33 times 8 equals to 264. 33 times 8 gives us 264. Then we add 5 to it plus 5. Press equals or enter. That gives us 269. So that means our second result is 269. Since 5 is our last digit here, that means our final answer will be this second result, which is 269 in base 10. So the value, the conversion from 415 in base 8 to base 10 will give us 269. Let's now look at example 2. In this example, we asked to change 231 in base 5 to base 10. So we're going to use the same successive multiplication that we used in our example 1. Write out your number, and then the next thing, we write our formula: first digit multiplied by the given base plus the second digit. That will help us to produce our first result. So what is our first digit here? Our first digit is this 2. So our second digit is 3, and our third digit is 1. So first digit 2 multiplied by what is our given base? Our given base here is 5, and our second digit is 3. So that means we have 2 times 5 plus 3 will help us to produce our first result. 2 times 5 will give us 10. 10 plus 3, that will give us 13. So our first result is 13. Now the step 2. For the step 2 now, we're going to take this first result and then multiply by the given base and then add the third digit to it. So that means we have first result multiplied by given base plus third digit. That will give us the second result. So we have something like this: 13 multiplied by 5 plus 1. So 13 multiplied by 5, that will give us 65, then plus 1, that will give us 66. So our second result is 66. Okay, since 1 here is our last digit, that means our second result will be our final answer. So our conversion of 231 in base 5 to base 10 will be 66. Let's look at example 3. Still on successive multiplication, we are asked to change 2145 in base 6 to base 10. If you look at this very example now, this very example has 4 digits. Unlike our example 1 and example 2, we only deal with 3 digits. But this time around, we're dealing with 4 digits. Okay, write out your 4 digits. So we have the first digit here to be 2, second digit is 1, third digit is 4, and the fourth digit is 5. So if we apply the formula, we'll have the first digit multiplied by the given base plus second digit, and that will help us to produce our first result. Then if you see, the given base here is 6. So our first digit is 2 multiplied by 6 plus 1. So you can see that 1 is our second digit. So 2 times 6, that will give us 12. 12 plus 1, that will give us 13. So our first result is 13. Okay, the step 2 now, we're going to take this first result and then we'll multiply it by the given base, and then we add the next digit, and the next digit is the 4, which is the third digit. So with the formula, we have first result times given base plus third digit will produce our second result. So we have 13 multiplied by 6 plus 4. Okay, 13 times 6 equals to, that gives us 78, then plus 4, then equals to, enter, that gives 82. So it means our second result is 82. Okay, since this 4 is not our last digit, our last digit is 5, that means we are still going to go to step 3. Step 3 now, we're going to take this second result and then we'll multiply by the given base, and then we add the fourth digit, which is the last digit there, 5. That will help us to produce our third result. So we have the second result times given base plus third digit will produce our third result. So we have 82 multiplied by 6 plus 5 equals the third result. Let's use our calculator to do that. 82 multiplied by 6, that equals to, enter, that gives us 492, then plus 5, that gives 497. So our third result is 497. So since the 5 is our last digit there, that means our third result will be our final answer. Final answer is 497 in base 10. Now is the time to talk about power expansion method. Power expansion simply means the use of power to expand the digits of a particular number. For instance, if you're given this particular number a, b, c in base n, we assume a to be the first digit, and b to be the second digit, and c to be the third digit. The c right here is the last digit in this particular number. We just assume this is a number. Then the last digit, that is where we start the first power from, and the first power is going to start with 0, and the second one, that's the second one as we are moving towards the left hand side. So we'll move from the right hand side towards the left hand side. So the next one as we're moving will be 1, the power 1, and the next one as we're moving will be power 2. So from here now, if we move from our right hand side, the last digit will have 0, the next digit will have 1, and the next digit will have a power of 2. Okay, for us to now expand this particular number, what we need to do is to take up the first digit, multiply it by the base, and then raise it to the power that is on top of that particular digit. So we have the power here to be 2, so that means we have equals to a multiplied by n raised to power 2. You get the idea? Then you now say plus again, you go to the next digit, which is the b. You say b multiplied by n raised to power the power on top of the b, and the power is 1. b times n raised to power 1, and then you say plus again, you c times n raised to power 0. Okay, let's consider an example. So in this example, we are given 101 in base 2. So all we need to do is to use the power expansion method to expand this. So to expand these digits now, so all we need to do is to raise them to power. So this 1 is the last digit here, so that means we're going to start the first power from it, and the first power there will be 0, following by the next one. So we're moving towards the left hand side. We'll start from the right hand side towards the left hand side. So this 1 will be 0, and this 0 will be 1, and this last one here will be 2. So we have 0, 1, 2. Okay, the next thing now is to take up the digits and then multiply it by the base, and then raise that base to the power that's on top of that digit. That means we have 1 times 2 raised to power 2. You can see that. Then plus, we take up the next digit, which is 0. That's 0 multiplied by the base raised to power this power, which is 1. 0 times 2 raised to power 1. Then plus, we take up the next digit, which is the third digit, 1 multiplied by the base raised to power that power that is there, and that power is 0. So 1 times 2 raised to power 0. So this is just a method that you can use for solving your power expansion method. Just sit back, I will show you different example on this. Let's look at example 4. In this example 4, we're going to be making use of the power expansion method for us to convert our bases. We asked to convert 415 in base 8 to base 10. Okay, write out the number first. That's the 415 in base 8. Then the next thing to do, we are making use of power expansion method. So we need to raise this digit to a power. So what is the last digit here? The last digit is 5. That means we'll start our power from this 5, which is the last digit. And that's the first one will start with 0. The next one will take up 1. This 5 will start with the power of 0. And then this one will start with 1, and the 4 will start with 2. So 0, 1, 2. You can see that we're moving from the left hand side. Oh, pardon me. We're moving from the right hand side to the left hand side. Okay, the next thing to do now is to take the first digit, multiply it by the base, and then raise the base to the power on top of the digit. So that means we have 4 times 8 raised to power 2. Then we now say plus, we'll take up the next one, and the next one is 1 times 8 raised to power 1. You can see that. Then we now say plus, we take up the last digit now, and the last digit is 5 times 8 raised to power 0. You can see that. Okay, the next thing to do now is, 8 square means 8 times 8, and that should be 64. So that means we have 4 times 64 there, then plus 8 raised to power 1. That will give us 8, because anything raised to power 1 will still be that same thing. That's the reason why we have this 8 here. Then 8 raised to power 0 will give us 1. Anything raised to power 0 is always 1. So that's the reason why we have this 1 here. Okay, so you can see that now. Then the next thing is for us to multiply 4 times 64. You can use your calculator to do that. So that will give us 256. Then 1 times 8 will give us 8. And 5 times 1 will give us 5. So that's the reason why we have 256 here for 4 times 64. So add them up together and you have the answer 269. So the conversion of 415 in base 8 to base 10 is 269. You can use your calculator to cross check that if you need to know whether your answer is correct. You know base 8 is oct, that's octal number, and then base 10 is decimal number. That means both of them is in the calculator, so you can use your calculator to cross check. Okay, before you check your answer, you need to be sure that your calculator is on number base. So to take your calculator to number base, go to your mode, press your mode, and then you can see the number right here, 2. So press it 2. So this might not be on your calculator. I'm going to press 1 here. When you press it 2, it might just take you to your number base direct. Okay, we're in number base now. You can see when you press this one is decimal, this one is hexadecimal, and this one is binary, and this one is octal number. So since we are dealing with octal, base 8 and base 10, so that means we are dealing with dec and octal. So we are converting from octal to dec. So let's put it on octal first, and then we'll type the number 415. This one is in base 8 already, and then let us press the dec. So dec now, you can see our answer there is 269. That means we are correct. Okay, let me also show you example 5. We asked to convert 1101 in base 2 to base 10. The first thing you need to do is to write down the number, and then we're going to make use of power expansion to solve this problem. Okay, from our power expansion, what is the last digit here? The last digit is this 1 here. This 1 here is the last digit. So that means we're going to start our power from it. The power on this 1 will be 0, and then the next one will be 1, next one will be 2, and next one will be 3. So we're moving from the right hand side to the left hand side. Take note of that. Okay, we start the expansion proper now. We'll take the first digit, we'll multiply by the base, and the base here is 2. 1 times 2, and then we'll raise that base to the power that's on top of the digits. So 1 times 2 raised to the power 3. That's what we have there. 1 times 2 raised to the power 3. Then we say plus, we have to do the next digit now. That will be 1 times 2 raised to the power 2. You get that? Then the next one will be the third digit, 0 times the base raised to the power 1, 0 times 2 raised to the power 1, and then the last one there will be 1 times 2 raised to the power 0. Okay, you get this now. The next thing to do now is to try to get these values. 2 raised to the power 3, and that means 2 times 2 times 2. 2 times 2 gives 4. 4 times 2, that is 8. So we have 1 times 8 there. Then 2 raised to the power 2, that's 2 times 2, that's 4. So we have 1 times 4 there plus 1 times 4. And the next one, 2 raised to the power 1. Anything raised to the power 1 is that same thing. So 2 raised to the power 1 is 2. Then we have plus 0 times 2. Then the next one, we have 2 raised to the power 0. 2 raised to the power 0 is 1. Anything raised to the power 0 is 1. And then we have plus 1 times 1. So let's do this now. 1 times 8 will give us 8. 1 times 4 will give us 4, and 0 times 2 will give us 0. Anything multiplied by 0 will give 0. Then 1 times 1 will give us 1. So we have something like this: 8 plus 4 plus 0 plus 1. 8 plus 4, that gives us 12. Then plus 0 is we still have 12. Then plus 1, and we have 13. So our conversion of 1101 in base 2 to base 10 give us 13. So 13 is our final answer. Let me also show you example 6. In this example, we asked to express 2145 in base 6 to base 10. First thing you need to do, remember that we are making use of the power expansion. Write down your number first. That's the 2145 in base 6. And the next thing is for us to start the power expansion. But before that, you need to raise this digit to their powers. So which one is the last digit here in this number? The last digit is this 5. That means our power will start from this 5, so we take it from our right hand side to the left hand side, and we have 0, 1, 2, 3. You get that? Okay. The next thing to do now is for us to expand these numbers. And to expand it, we take the first digit, we multiply it by the base, and then we raise it to the power that is on top of that digit. That's 2 times 6 raised to the power 3. So we have something like this. Then the next one will be the next digit. That is 1 multiplied by 6 raised to the power 2. You get that? So you have to put plus there. And then the next one will now be 4 times 6 raised to the power 1 plus 4 times 6 raised to the power 1. And the next one now will be this 5 times 6 raised to the power 0. You get that? Okay. Next thing to do now will be, we have 6 raised to the power 3, which means 6 times 6 times 6. So you can actually use your calculator to do that, but if you can use your brain to do that, no problem. 6 times 6 will give 36, and 36 times 6 is going to give you 216. So you can make use of your calculator to do that. So we now have 2 times 216, and then the next one right here, 6 squared, that's 6 times 6, that gives us 36. So we have plus 1 times 36. And then the next one, 6 raised to the power 1, that is 6. Anything raised to the power 1 is that same thing. So we have plus 4 times 6 there. And the next one, 6 raised to the power 0. Anything raised to the power 0 is 1. So we have plus 5 times 1. Okay, the next thing to do now is we'll multiply the 2 times 216, and then we'll multiply through, and then we have for 2 times 216, we have 432 there. 1 times 36, we have 36, and 4 times 6, we have 24. 5 times 1, that is 5. You can use your calculator to multiply this so that you be sure. So using your calculator again, you can just plus them together. 432 plus 36 plus 24, then plus 5 using your calculator. So your answer will be 497 in base 10. So converting 2145 in base 6 to base 10, the final answer will be 497.
We have come to the end of this lesson. We do hope you enjoy every bit of it. If so, don't forget to subscribe to the channel if you have not done so. Like our videos and then hit on the bell icon to get notified. Thank you for watching.